I have a problem here that I'm going to demonstrate the relationship between the radius and a tangent line. So first here it says SR is tangent to circle P. So SR is tangent to circle P. So the point in which it touches the circle is the point of tangency. The fact that we have this radius here now makes a right angle. So the radius and the tangent line are going to be perpendicular at the point of tangency. So you can see that we have a right triangle. Well, we have another triangle here that also has a point of tangency, because SR is not only tangent to circle P, but it's also tangent to circle Q, and QT is a radius, so we have another right angle making another right triangle. Additionally, this is getting good. Additionally, triangle RTQ is going to be similar to triangle RSP, which is going to give us some angles that are congruent and some proportional sides. So let's take a look at the given information. QT has a length of 6. TR has a length of 8. Before I read any more, I'm already getting a little anxious here because I see a right triangle and I see that I have a 6, 8, 10 triangle. That's one of those Pythagorean triples. So 6, 8, 10, those Pythagorean triples occur in right triangles. The largest side is the hypotenuse. So I just pause, I take a step back, and I fill that in. So I filled in the 6, the 8, now PR is 30. Well, now that I've filled in QR is 10, I know that PQ is going to be 20, so that this entire segment can be 30. So this is some pretty cool stuff. I also know that since I have those parallel lines, I'm just going to start filling in everything I know. I know that 8 is to 10 as ST is to 20. So that's going to make ST equal to 16. You can cross multiply and divide. You can also see that we multiplied by 2, multiply by 2 to keep that ratio consistent and constant. We're going to get ST is equal to 16, so I'm going to fill that in. That's 16. We need to find what PS is. It's the last missing piece. Well, I've got a leg of 24, so that's 24 squared. I can do that. Plus, we'll call PSX, x squared, equals 30 squared. So that's one way that we can find the length of PS. There's another way that we can find the length of PS. Because we have similar triangles, we have some ratios that are very, very convenient. So I'm going to come over here and I'm going to say, well, we've got 6 is to x as, we can do this side to this side, so TQ to SP is to, I like the hypotenuse, so let's do RP. So TQ is to SP, TQ is to SP as RQ is to RP. So TQ was 6, SP is X, RQ is 10, and RP is 30. So we've got 10 times X equals 6 times 30. We'll divide both sides by 10. And we get X equals 6 times 3 is 18. So SP is equal to 18. So SP is the same thing as PS, so that's 18. PQ is 20. And ST is 16. So you can see we filled in lots of information there. Lots of information. Okay, in another video, I'm going to come back and look at the next two problems. So if you want to take a look at those ahead of time, you can go ahead and do that. Otherwise, I'm going to come back in the next video and we're going to do those problems.